Hi, good afternoon. My name is Ajayi Simeon Ayooluwa. All right, so I'm here to make a brief presentation on my special topic project on environmental toxicology, which is a course I'm offering this semester, spring 2024. All right, and the semester project is basically meant to do two roles from so two roles basically for us to kind of look at particular agents, all right, that have relevance, all right, relevance to our environment, environmental health, and public health, all right, be it chemical. So these agents can be chemical, they can be radiological, they can be biological, and it can be physical as well. And then so it has to do with the environment, and then there has to be a lot of current research being done on the work as well. So basically that's that. And then also this is also meant to make us to be able to um, of course, research, go into the books, go into the journals, get a lot of research on each of these topics. So for me, I chose methyl isocyanate and then harmful agar blooms. All right, so I choose chemical and then biological. The chemical being the methyl isocyanate, and then the biological being the harmful agar bloom. So yeah, so to start with, my name is Ajayi Simeon Ayooluwa, like I mentioned earlier. So to start with, literature review of the public health impact of methyl isocyanate. So as a form of introduction, methyl isocyanate is a chemical compound that is widely employed in the production of pesticides, all right, pharmaceuticals and polymers. So methyl isocyanate is the compound that is widely used in production of pesticide as far as and it has been in use as far as back as late 80s and the early 90s. All right, and it's majorly majorly relevant in the use of pesticides, carbamate pesticides, in fact. All right, so and of course, this has been what the chemical has been used for earlier. So, so it is crucial to comprehend the detrimental impact of methyl isocyanate on human and public health, given a severe effect and past industrial disaster. Okay, so I'm going to talk about one certain event which really brought the harmful impact of methyl isocyanate into fore. All right, in history. Okay, so majorly this event is Bhopal disaster, all right, which happened in India. All right, so this chemical was being used as one of the raw materials or raw agent in the production of pesticides in that company, Union Carbide company. All right, so due to negligence of this people of the workers there, the chemicals was the machine mixing the chemical, storing the chemical, using storage chemical wasn't handled properly, and then overnight, and then before the following morning, the chemical had spread to the nearby environment, and then there are a lot of thereby causing a lot of acute and chronic health impact or effect on the public. All right, and then that event really marked a kind of it's a point of reference in the history of this chemical. All right, before then, much were not really said about the chemical or about the much were not said about the health impact of the chemical. But after then, there's really been a lot of research, even till now. There are a lot of chronic health effects that's still being researched up till now that we are speaking. So therefore, it makes it imperative to research the acute and chronic health effects of methyl isocyanate, and develop effective treatment. So talking about the history, I already mentioned it. It can be traced back to industrial development in the 1960s and in the use of carbamate pesticides. All right, so the most notable incident was Bhopal in 1984, which occurred as a result of a pesticide plant in Bhopal, India. So discovery it was first discovered or synthesized in 1884 by German chemist named Theodor Curtius. All right, so in the early 20th century, and it started being used to produce various chemicals, all right, various chemical intermediates, like including pesticide, herbicide, and pharmaceuticals. So basically, looking at the physical properties, it's a methyl isocyanate is a colorless liquid that has a sharp odor, all right, and also the odor threshold is you can see the odor threshold and also the molecular weight and the vapor pressure as well. So talking about how these properties relate to the health impact. So MIC was chosen as a key intermediate due to high reactivity and ability to form a wide range of carbamate compound. However, the inherent hazards of MIC include the flammability, toxicity, and potential exothermic reaction were recognized in the study done by Broughton in 2005. So MIC has been found to be extremely toxic to humans, all right, to humans. So talking about the, I'm just going to have a limited time, so I'm just going to be running through it. So this is just talking about the industrial production, where I mentioned before, where a lot of companies were beginning to use, before the incident, of course, were beginning to use industrial companies are beginning to use a lot of these chemicals, MIC, to produce. All right, so basically, it's that's what this place is talking about. And then talking about the public health issues. All right, so how this public health issues, how it was studied, or how it was brought to fore. So scientists have studied the public health issues related to methyl isocyanate since Bhopal disaster in 1984, and the gradual process is driven by scientific research, molecular studies, and industrial accidents. All right. So basically, industrial accidents really formed the backbone of how the study of this particular chemical came into form. All right. So the Bhopal disaster caused a massive release of MIC gas from a pesticide plant operated in Junior Carbide Corporation, right? And it resulted in immediate death and long-term health impact. All right. We draw a global attention to that. Okay. So also epidemiological studies were done to assess the health effect of MIC exposure to the population. All right. So till now, then till now, epidemiological studies is still being done to really know the impact, how much of the people that were exposed to these particular chemicals have been brought down or are developing certain disease, of course, which is going to be chronic now. Then it was acute, and then now chronic effect. Also, toxicological research was done, and it identified 2 ways it exerts toxic effects on various organ systems as well: risk communication and public awareness and regulatory responses. So talking about the power transformation, it's highly reactive, like I mentioned earlier, and then it can lead to cellular damage and adverse health effects. All right, so basically, it's going to be the major pathways it goes through in the body is hydrolysis, which is the primary pathways where it reacts with water to form methylamine, and also glutathione conjugation. All right, when in the liver, when it joins, when it's being conjugated by glutathione, and then which is an antioxidant as well, and then this helps to detoxify the reactive compounds and to help it to form a stable adduct. All right, and then oxidation is another metabolic pathway, and which is mediated by the cytochrome P450 enzymes in the liver, and then it can lead to formation of reactive intermediate and metabolites, some of which will be more toxic than the parent compound as well. So the result of this is to form a water-soluble chemical or agent or metabolite. Let me put it like that. So which is, and then it's going to be there's going to be easy excretion by the kidney. So talking about the impact as well. So the acute impact of methyl isocyanate ranges from respiratory distress, pulmonary edema, high irritation, skin burns, and neurological symptoms. So inhaling MIC can also result into respiratory and ocular irritation, which, while contact with MIC, can cause skin burns and dermatitis. So, and then there are studies to really talk on that as well. So chronic exposure basically has been found to be linked with respiratory and neurological problems, and then reproductive toxicity and possibly cancer as well. Although the link between cancer and then exposure to methyl isocyanate has really been it's not yet established, but studies have really found out, have really suggested some linkage or some linkages. All right. So also on the environment, it causes damage of the soil, the water, the air quality as well. I mean, going back to when the incident that happened in Bhopal, a lot of the environment, or a lot of the environmental content, the air, the soil, they were all affected or contaminated by this chemical. All right. Also, bulk accumulation and biomanipulation. So MIC and metabolites can accumulate in food chains and increase in concentration as they move up to the food chain as well, and then also community risk as well. So scientific approaches to studying the impact of MIC on public and environmental health. epidemiological studies have been done to really ascertain this. Then toxicological studies also have been done, and as well environmental monitoring programs to detect and quantify the MIC in the environmental matrices. This helps to assess the trend in environmental contamination as well. Then exposure assessment too can be done. People that have been exposed, they can be examined to know, okay, how were they exposed, where were they when, I mean history, taking a good history can help to really ascertain this. Sorry for the pop-ups. All right, so how the impact is being addressed right now, basically regulatory frameworks, teaching people how to safely handle dangerous chemicals. This would have helped really to prevent the Bhopal incident. If there are really regulatory frameworks to provide it, that the workers that are using, or industries that are really using these chemicals as a raw material for their finished product are going to follow strictly. Also, risk assessment and management, also then manage emergency preparedness and response, community engagement and public awareness, and then environmental monitoring and remediation, and also research. So in summary, the tragic history of MIC is a stark reminder of the devastating consequences of industrial accident, and also underscores the urgent need for strict safety regulation. So the production of storage of MIC really poses a lot of significant concerns, which really underscores the reason why or the need for strict regulatory and frameworks, all right, to really guide the way like a protocol to really guide the way it's being used, it's being stored, and it's being produced as well. So yeah, so thank you for that. That concluded the literature review on MIC. So I'll be going to the second part of the presentation. This is my bibliography, my references, all right? So now to the second one, which is the literature review of the public health impact of harmful algal blooms. All right, so as form of introduction, harmful algal blooms are biological, like I mentioned earlier, they are biological agents as opposed to methyl isocyanates, which is majorly chemical. All right, so they are a significant ecological and economic concern, as they can produce toxic effects on variety of sea organisms, including humans, fish, shellfish, marine mammals, and birds. All right, so these blooms are often a result of nutrient pollution from sources such as agricultural runoff, sewages, and fertilizers, and the likes. So they provide an excessive amount of nutrients like nitrogen and phosphorus to the water, and then they usually thrive in warm and temperate regions. Excuse me. So they produce toxins that contaminate seafood and create dead zones in the water bodies as well. So talking about the history, all right, so the occurrence of harmful algal blooms has been documented throughout history, although our understanding of them has evolved over time. So in ancient times, throughout history, harmful algal blooms have occurred right from the start. And although ancient civilization may have encountered them without fully understanding their causes, consequently, reports of their discolored and foul-smelling water in historical texts that could be possibly attributed to algal bloom. So, however, the understanding was not as much refined then, but over time, because of their linkage to death of water bodies, fishes, and the likes, really spurred up a lot of research that were done. So in ancient Greece, Pliny the Elder described the red tide, which was arguably one of the first research or studies that were done on this particular agent. So they discovered that it caused the death of fish and birds. All right, so for many years, harmful algal blooms research was conducted in relative isolation. However, individual researchers or countries can run programs independently with few taking a global perspective. So the first effort to provide a global perspective on the trends was done by research done by Anderson and Allegre. They argued that there was a global increase in the frequency, magnitude, and geographical extent of HABs over the preceding 2 decades. And this is due to two reasons basically that they found. They found that there were a lot of natural dispersal of the species of the current, all right? By current, of the species of the harmful algal blooms by current and storms as well, which made it widely distributed, and then dispersal through human activities as well. All right, so this was one of the previous or first study that was done. And in the 20th century, it was this research increased, and then we started talking about this was when we started talking about the ecological impacts, and then also the toxin production. So this was when the various types of toxins that were produced by these particular agents were being identified, or also. So they really they identified the species of the algae that form blooms and then produce toxins. So basically, the two major species that were found was by the dinoflagellates and then the cyanobacteria. So in 1930s, the first major HAB event was reported in the United States, where the consumption of contaminated shellfish led to paralytic shellfish poisoning and several human fatalities as a result of the consumption of this shellfish. All right. So in recent decades, over the past few years, technology has really enhanced the ability to monitor and detect HAB. So since then, a lot of reporting of the incidence of HABs, the distribution, the geographical distribution, the frequency, intensity, and then incidence of the poison as well. So in 1980s, the first cases of Ciguatera fish poisoning were reported in the United States, caused by consumption of reef fish contaminated with Ciguatera toxins. All right. They are majorly found in fish restricted to warmer or subtropical and tropical regions. So talking about the public health issues, looking at the ecological observation, throughout history, people have noticed abnormal changes in water, the contribution, they notice the abnormal changes in the color, the odor of appearance of water, and then, of course, over time, this has been attributed to the presence of this harmful algal blooms, all right, and then which are often linked to mass fish deaths or other ecological destruction. Also, scientific research as well, like I mentioned earlier, during the late 19th and early 20th century, started studying after noticing a lot of its effect, but without being able to identify what the particular cause is. So the research were done, and then they studied it, and then they noticed particular species of algae which could reproduce quickly under specific circumstances, resulting in dense blooms. Right. So toxicity discoveries as well they were able to get this as well. So they discover certain types of algae that have the ability to produce harmful toxins as well. And then human health incidents too. So there are a lot of illnesses and death that has been associated with consumption of contaminated seafood, which has brought attention to the problem of harmful algal blooms as well. So now talking about before I go forward, here research were done, and then they found prominent toxins, all right, that has been associated with that have been found in harmful algal bloom related illness, which are the ciguatera poisoning, paralytic shellfish poisoning, neurotoxic shellfish poisoning, amnestic shellfish poisoning, and diuretic shellfish poisoning. This was found in a research done by Grattan et al. All right, so talking about biotransformation, usually the head was happen, usually exposed, human beings get exposed to it, most times via ingestion. So it's been ingested, and then maybe through seafood, through contaminated water, and all sorts. And then absorption is usually in the bloodstream, and then it affects the organs and tissues, depending on the specificity of the toxins. Like I mentioned, there are 5 toxins. So there are some that neurotoxins, which affect the brain, diuretic, which affect the gastrointestinal system, and the likes. All right. So depending on where they affect, the toxins are designed in such a way that they have specificity for the specific organs that they are affected. So talking clinically now, depending on the symptoms the patient comes down with, now can say something about the toxins, all right, or which type of toxins the patient was exposed to. So biotransformation, talking about biotransformation, deliver detoxified toxins through the enzymatic reactions, and then make them water soluble and easier to excrete. They look at the toxification pathways, phase 1 reactions, that's where they have hydrolysis, forming body adding hydroxy group to the toxin molecule, making it more reactive, then conjugation reactions, and then enzymatic reaction as well. Then excretion, of course, the metabolite is after being conjugated to form a water soluble compound, and then it's being excreted through the urine or feces. All right, so exposure to the toxin can cause adverse effects, health effects, gastrointestinal effect, neurological, respiratory system, organ damage, and death. So talking about the public health and public and environmental health impacts of harmful algal blooms, they pose a significant threat to the public and environmental health. So one is one is uh, it poses, so number one is toxin production and human health impacts. All right, I'm sorry about that. So during blooms, many species of the algae can produce toxins such as microcysteines and saxitoxins. All right, so these toxins can contaminate water sources and pose serious health risks to humans and animals through ingestion or skin contact. So this is an example of toxins. Also, it can cause habitat degradation. So because I mentioned that the first consumer or the first level of exposure to these toxins are usually the human and the animals or the water bodies, all right? The water animals, all right, the aquatic ecosystem. So they are the first to experience the toxin, and then they are the first to get depleted. So this can lead to a lot of habitat degradation, all right? Economic impact as well. People that rely on sales of seafood and all and the likes, this can, if a lot of these can cause death of these water bodies or water animals, aquatic ecosystem, and then of course it will reduce their source of income. All right, so climate change as well is expected because if there's a warm, this organism grow in a warm climate. So if there's a warm climate and all, it's going to like increase their growth, and then it's going to cause a lot of harmful effects. So how the issue is being studied, basically, the studying issue requires a multidisciplinary approach, such as ecology, biology, toxicology, oceanography, limnology, chemistry, public health, policy, and management. So of course, tools such as field monitoring, remote sensing, and computational modeling are used to understand the complex interaction between environmental factors, algal physiology, and impact of harmful algal blooms. So how the issue is addressed: monitoring and early warning systems. So there should be warning systems on ground to be able to detect the formation and movement of these blooms as well. Then the regulatory policy measures to limit the source of nutrient pollution, especially because these blooms they thrive in warm, moist environment. All right, so such should be prevented, especially agricultural runoffs, wastewater discharge. There should be a strict regulation of to prevent a lot of these. All right, so development of water quality standards as well. Then mitigation and remediation strategies, exploring methods to control the harmful growth of harmful algae physically, chemically, and biologically. Use of algicides, nutrient binding agent, and the likes. So public education and outreach, raising public awareness about the risk and impact of harmful algal blooms through educational campaigns as well. So research and innovation, like what has really a lot of research been done, I mean, up to date, and it's still being done. So to better understand the complement mechanism and then other factors that hate the growth of harmful algal blooms as well. So also interdisciplinary collaboration, like I made earlier, the scientists, the oceanographers, the environmental managers, public health officials, and even clinical professionals like doctors, nurses, and the likes. So the collaboration of these people will help in better understanding the intricacies of the effect, the growth, the effect, and then the regulatory mechanisms that can be put in place. So in summary, the past occurrence of harmful algal blooms serve as a reminder of the enduring threats to both aquatic environment and human well-being. So this event results in problems such as contamination of drinking water and death of fish. So it's crucial to take swift action to address their impact on public and environmental health. So key solutions like I mentioned earlier are really very important in preventing or reducing their effect on the environment. Thank you so much for your time. So that will be the end of my presentation. Thank you.